Assalamualaikum warahmatullahi wabarakatuh and a very good morning or evening. I bid to Dr. Abdul Halim. My name is Abdul Muhammad Hazam bin Shamsuraji. So today I will be presenting about 3D interpolation using Gershberg-Saxton algorithm. So during this presentation, first we will start off with the introduction part about this presentation. Next, I will talk about the four objectives of today's video presentation. And next, we will move on to the 3D interpolation basic theory. I will talk briefly about it from the literature review. It covers more on the basic about mathematical part. After that, I will introduce you about the Gershberg-Saxton algorithm. How does it work? And next, the 3D interpolation process in this video. After that, I will try to help and guide on how to do the Gershberg-Saxton algorithm step by step from the beginning until to the end. So after we have complete all the Gershberg-Saxton algorithm, we will discuss more about the limitation and benefits using this method. And lastly, we will close this presentation with the conclusion. Okay, some of you may ask, what is the use of the seismic interpolation? So when we do exploration, when we get the seismic result, 99% of the times we will get an incomplete seismic due to the different reasons. Some seismic surveys generally have irregular areas where data cannot be acquired, and those data, the missing data, should be interpolated for the interpretation. So 3D interpolation process of seismic data is aimed to reconstruct, synthesize, or recover missing trace due to the noise induced or divergence of the wave. Okay, so next we will move on to our objective. So in this presentation, we will try to complete these four objectives. First is to discuss about general mathematical concept of 3D interpolation. Second is to talk about general problem using outdated threshold value, the LO and L1. And then the third one is to look at a different, newer and updated method of interpolating 3D seismic data, which in this case, we will try to look in the Gershberg-Saxton algorithm. And the last one is to discuss about limitation and benefit of using Gershberg-Saxton method. Okay, so here is the basic theory of the 3D interpolation. As we can see, this is how interpolation was presented in the mathematical approach. So the basic formula is D equals to MDR, where D is the observed data, M is the sampling matrix, and DR is the unknown data need to be reconstructed. Okay, so since this is a very simple formula, the M could be any value from negative infinity to infinity. So when solving this problem, some constraint or regulation need to be forced when solving this formula. And from here, we can see that different people have tried different approaches to find the most accurate reconstruction approach. So the two most widely used regulation are the L0 and L1 to constrain the transform domain coefficient. But since LO norm regulation will make the algorithm harder, causing the algorithm have more problem, or we can call it as NP hard, and L1 regression, the lasso regression, have a non-sparse solution. So a lot of model being introduced until today. And today we will discuss specifically in looking at a more recent method, which is using the Gershberg-Saston algorithm and projection onto convex sets, or more known as POX, image restoration algorithm. So this method is one of many methods to restore the missing trees in the seismic datasets. So the Gershberg-Saston method used 2D Fourier transform to interpolate missing samples in photographic image. So here is the basic that we should know about the Gershberg-Saston algorithm. So the Gershberg-Saston algorithm is an iterative phase retrieval algorithm for retrieving the phase of a complex value wavefront from two intensity measurements acquired in two different planes. So typically, the two planes are the image plane and the far field diffraction plane. And then the wavefront propagation between these two planes is given by the Fourier transform. Okay, so next we will move on to the 3D interpretation process. So first, what we need to know about the Gershberg-Saston algorithm method to do the interpolation. First, it is a repetitive method. So you need to iterate the cycle many times. So for each cycle, first the data will undergo first the 2D Fourier transform, and then the process of thresholding or filtering, so that the transform data will only leave the highest amplitude and it will filter out all the low amplitude. And then the third one, um, we will inverse transform of the result that we get from the threshold. And then last one, we will reinsert the threshold result that have been inverse transformed into the original trace that have no filtering. Okay, so in step 1, we can see that it says 2D Fourier transform, but from the paper that I have read before, it says that it also can be applied on the 3D, where the 3D need to add one more set of Fourier transform to change it from 2D to 3D. Okay, and then on the step 2, during the thresholding part, so when for the first cycle, the thresholding will use the strongest frequency wave number, strongest FK component, so that it will remove all of the low amplitude, and then as the cycles continue, the threshold value will be lowered so that the finer details also can be interpolated. And lastly, the post technique produce a good result, especially when dealing with the irregular space data. Okay, so from this slide, I will try to explain step by step on how to do the interpolation process with the example using synthetic seismic data. So from the first picture, we can see that there is a missing section here. So we will try to use the Gershberg-Saston method to interpolate the seismic and fill the gap in the seismic slice. So even though that we can see the example being done in 2D, but it also can be done in 3D. And it took a long time to do in 3D, so and it is more easier to understand in 2D. So okay, so the objective of this process is to interpolate the missing synthetic seismic data. So first, the first step is Fourier transform. So the synthetic seismic data will be changed from time domain into the frequency domain using the Fourier transform. Okay, and then, so since the seismic data already in the Fourier domain, we can actually try to filter it. First, we will remove the unwanted data. So the low amplitudes that were below the set threshold were being removed or muted in the Fourier transform domain. So we get the image on the right, a clean seismic with only high amplitude value. So after the filtering process, we have get the high amplitude value. We will change back the after filtering seismic into the time domain back, which is by inverse transform back the applied threshold result from the frequency domain to time domain. So the D here is the result that we will get after we inverse transform the high amplitude value. Okay, after that we only left with one more step, which is the reinsert of original trace. So here is the final portion of the iteration process. After we have the inverse transform of high amplitude seismic, we can take the part of missing section after Fourier transform, thresholding, and inverse transform back and fill in the original traces missing section of seismic data, and we will get the result as the figures below. And we finally complete all the steps for the Gershberg-Sastor interpolation. So the data that was shown here has many ringing, but as we do more and more cycle, the ringing effect will be lowered. Okay, so now that we know how to do the interpolation process using the Gershberg-Sastor method, we will move on to the limitation and benefits of using this method. Okay, so here is the limitation and benefit of using the Gershberg-Sastor model. So the first one is I need to remind you that the sample that were demonstrated earlier is a very simplistic model. It is a synthetic seismic data. So a real seismic will require extra steps such as zeroing the spatial naiquist, the analyzing interpolation process. So what we have done earlier is for the sake of understanding the concept, but a real seismic data will have more iteration. And then the second limitation is that this method is costly if we compare it to the other method, because when we talk about this method, it requires a lot of iteration. So it uses a lot of uh, computer power or computational program. And then the third one is noise can affect the interpolated result. And then the benefit of using this method is that we can interpolate any given missing traces. And then the second one is the quality of the interpolation are significantly better than a typical method. So the conclusion here is that there are many methods of interpolation, and Fourier method is one of the many methods that are available. So even though the results are good, but the most critical point of this method is to know the number of cycles that need to be done, because when we overestimate the cycle, we may waste computational time. But if we underestimate the iteration process, the the seismic data will have a full result. And then the last one, the simplicity of this method is an advantage compared to the other method. So that's all from me for the presentation. So if you have any interest to take a deeper look in the Gershberg-Sastre model, you can refer to this citation. And if you have any question, don't hesitate to reach me out. So that's all from me. Thank you.